Okay, now we can start. So yeah, I will hand over to you directly.
Okay, so I will talk today about the setup on using generalhw backend that we use to test CubeSOS. If I get my camera working, let me see. So you can see in my background there is a rack standing. So this is filled with laptops mostly, and we use that to test CubeSOS on those laptops. So how does it work? Let me share screen. I think this will work. So here is some high-level overview. So there is a system under test, and to control that, to control it using OpenQA, each of them have a Raspberry Pi connected. So the previous generalhw was about testing things on Raspberry Pi, and now I'm using Raspberry Pi to test other systems. So it's using video capture over HDMI. This is the Raspberry Pi by default has only video output, but there is a small board you can attach to the camera interface to also capture video input over HDMI. So I'm using that. It's very similar to PyKVM project, and in fact, I took some inspiration from that. So this is the video capture part. Then to provide input devices like keyboard, mouse, I emulate mouse and keyboard over USB, and this is also done from this Raspberry Pi. So this is Raspberry Pi 4, so it on the same connector as the power input. It also can emulate this USB gadget interface. So this is also connected to the system under test. And then to reliably power on and off the system, I have power strips that are in each socket is individually controlled, and this would be enough for normal like desktop computers or something like that, like this. But for laptops, laptops have are mobile computers that have battery. So just cutting off the power, external power is not enough. So in most cases, I simply disconnect internal battery. But in some cases, I still need to do something to actually power on the system, because if I just connect the power, it's not turned on. So in some cases, it is I need to send some wake on LAN signal. In other cases, there is a BIOS settings that I can configure what should be the state after plugging the power in. But in some cases, I need something to physically press this power switch. And in fact, I have a photo of that, if I manage to open that. Let me here. There is article version of most stuff I'm going to talk today. So to press a power button on a laptop, I mount a servo motor that is pressing this button. And this servo motor is also connected to the same Raspberry Pi that is controlling the stuff. There are enough GPIO pins, so I can control that. Okay, so I have some power control, user interface input, capturing output. So what next? In case of testing Raspberry Pis, the system, the installation image or operating system was provided of using SD card, and there is this SD card multiplexer that you can switch card between a Raspberry Pi and some other system to replace the content. But in this case, okay, I could also boot the system from USB that is emulated on this Raspberry Pi, but it would be really slow. Especially in CubeSOS that is very heavy on storage access. So what I'm doing instead is to configure all those laptops to boot from the network. This is sometimes easy, sometimes very much not so, because I have about 10 or 12 of those laptops, and every single one of them is different. So in some case network boot is supported, in some case not, in some case I need to enter the menu during boot and specifically select it because it doesn't allow to set it by default, and there are a lot of different options. So my approach is to have some way to make it boot from the network, and then I have another Raspberry Pi. All of those computers that are controlling the test are about Raspberry Pi. So I have another one that is running the HTTP server and TFTP to boot from the to network boot from there. And when I boot from network, I can remotely over SSH here control what is actually starting. So the system will load some predefined configuration. It's mostly based on the MAC address of the system, and I can control. So this one, for example, will start some installation image that is exposed over HTTP from here. Another one will start the system from a local disk. Another one will start the system from some predefined rescue image, and so on. So this is using network boot, and then a bit of scripting in group configuration to load specific configuration, and then depending on the setting, boot the system. So I was saying that getting laptops to boot from the network is not easy. In some cases, it's not supported at all on a laptop. So I'm using a USB stick that is plugged into the laptop and configured to boot from there by default. And that USB stick has iPXE on it. And that iPXE fetches the configuration from here and start group, and then goes the same flow. I have a diagram of this somewhere here. Oh, here. So there are different ways to power on the system. Either it can be configured to power on automatically, or I need to send wake on LAN, or physically press the power button. Then using PXE boot over network, or I PXE loaded from a USB stick. Then I finally get to Grob, and then depending on the configuration, I start the actual system. And for that, I've made the nice convenient menu tool, so I can launch it with some argument to do an action. And the same tool is used also to control power, so power on and off. So this is also controlling this power strip. My diagram included one of them, but each of those power strips has 4 sockets, so I have 3 of them connected, and I'm slowly running out of USB ports here. I will need to improve that, but well, currently it works. Okay, so when I get I got something that started here. So the actual test will either run installation from the network that is mounted here, some installation image. In one of the cases, I provide the installation image over this USB, emulated USB, so it is USB storage. It is slow, but also this way I test also other methods, not only network install. But generally, this installs the system to the local disk on the laptop. Next test will take system installed this way to the local disk. So the OpenQA has this hooks for storing, saving the disk image, and flashing the new one. And in case of Raspberry Pi, it's used exactly like that. It's either dumping the image or flashing into the SD card. But in case of laptops, it's quite a lot of data, and that would require a lot more time and also space, and yeah, so I don't do that. Instead, when the system is installed, I in most cases I care about the final disk image. There's LVM, so I use LVM snapshots. And for that, I have a script here. Oh, okay, let it load. So there is a kubefirst tests HW setup repository. I've just made it public with just one commit. I tried to separate stuff that is very much specific to my setup to some config files, but still some of the scripts has some IP addresses or stuff like that, hard-coded. It's not easy to reuse, but at least it can be seen how it works. So there are 2 scripts, OpenQA store asset and OpenQA flash. So I will open both of them. So OpenQA store asset is saving the disk image, and yeah, there is some boot handling. But generally, where's the main loop here? It iterates over LVM volumes, and it's create a snapshot with some prefix snap ID, and as a thing that OpenQA saves as a disk image, I have a file with just this snapshot ID, which is just small random number. And when I want to flash the disk before the test, I restore those snapshots. So there is similar loop here, and that remove the original volume and create the one to be tested as a snapshot of this snapshot. And there is some handling for boot partition and probably a few more details that are not on LVM. Yeah. So this means when I install system on one laptop, I can use this disk image. Well, disk image that is actually snapshot ID only on the very same system. So this has some challenges for test scheduling, because I cannot, for example, start the installation test on one and then run other tests on another laptop, because the snapshot disk snapshot won't be there. But on the other hand, I do want to test control which tests are running on which machine, because they are different. For example, there are different video drivers that I want to test. They are different. On some laptops, Suspend works well. On some, it doesn't. Some are using Wi-Fi. Some are using wired connection. So there are different tests to be run depending on the specific system. Okay, so that's how the disk is connected here. Capturing video. This is something I extended in OpenQA, because normally OpenQA expects VNC connection, and I could has some yet another service running here that wraps the incoming dev video 0, or actually it's I think it's dev video 0 into VNC connection. And in fact, somebody already written something like that, and it's also part of a PyKVM project. But the processing power on Raspberry Pi is limited, and I'm also running OpenQA worker there. So I wanted to save one translation. So OpenQA worker is starting FFmpeg that is extracting data directly from this open dev video 0. And to do that, let me find the configuration. I think worker conf is created here. So workers ini configuration file has all of those settings, and especially generalhw video stream URL is simply dev video 0. And when and this is when this stream URL instead of VNC IP is used, it's supposed to be something that FFmpeg will take as input. So if you provide just the video 0, it just works. For the input control, there is input CMD, and there is yet another script, OpenQA input, and this one. Okay, let me go here. Input. Oh, okay. This was is very simple, because it just connects to Unix socket. But that Unix socket is created using this gadget control script. And this one is setting up USB gadget. It has several functions. One is keyboard. Let me find there is some magic. I will talk about it in a moment. So I have a keyboard device, mouse device, and optionally also storage. Where is storage? This should be up-to-date version. Here is okay. There is also storage when it's enabled. And for keyboard, that is easy. For keyboard, every keyboard is the same. It works. So for keyboard, I have okay. I needed to write USB HID descriptor, but this one is very much very generic. But for mouse, I had yet another challenge because if I use just mouse, then I have a control over a relative mouse position. So I need to know from where it was before to move it to some place. At the system start, it is in the middle, so I could make some calculations there. But then some events reset this position, and I would need to detect that. For example, logging out of the X server or restarting or something. So that would be really messy. Instead, I wanted to have absolute position of the mouse, and for that I need something like a USB tablet, and there is and for that I needed to write this USB HID description, but to have a tablet correctly working, I needed to make both UDEF and X server to detect this device as a tablet. And they have a set of heuristics. For example, device to be detected as a tablet, it needs to report absolute position. But also it needs to have specific buttons like stylus or digitizer. It needs to be there. But then having input device like this, I wouldn't have normal clicks like left button, right button, etc. So I have, in fact, a device that have two pointing devices. One is stylus, as required to be detected as a tablet, but then also a mouse that have just buttons to be pressed. And where is, yeah, there are 3 buttons. So yeah, that was quite frustrating to get it right, because apparently very few people need to write things like that. So I was using directly USB specification. Yeah, that was painful, but it works. And then when those input devices are set up, then I simply write to the device what specific events. So there are reports for moving mouse. So this is moving stylus, for pressing a button, or for keyboards. Yeah, for keyboards it is simply a separate device. And then OpenQA sends input devices, input events in a way that QEMU would, or VNC would understand them. No, QEMU. Yeah, I think QEMU. So I needed to make a translation table to the stuff that USB gadget would understand. So there is a big table. Yeah. And then there is simply line-by-line processing. So when it's mouse move, then there are just coordinates as arguments. Mouse button, then there is a bit mask of what buttons are to be pressed. And everything else, there is a convenient command type to send several keys. So I can also use this interface manually. It's not very convenient because I need to type a word type and then the thing I wanted to type. But if I don't have other options, then it works. And also there is detection of various modifiers, and finally it sends the input event here. And thus handling socket. Okay, so I think that's it about this connection. For connection here, so I was showing this SSH interface. The direction of the arrow is not really accurate. So I have this menu. In fact, currently it's a bit extended because there are a bit more boot entries. So I have power on, off, reset is just an alias for off and on, wake. This is supposed to wake from suspend because I also test system suspend. In some cases, it is pressing the power button. In some cases, it sends wake on land signal. I think that's currently all the options, but maybe at some point it will need yet another case. Who knows? And then select what to boot. So when I boot a rescue system, that is simply some kernel initial RAM disk loaded from the network. That's easy. The custom, or in fact there is another boot option to specifically for OpenQA to load the system from this Raspberry Pi. This also is just loading the kernel and initial RAM disk over the network. But surprisingly, when I want to start system from local disk, when the system was started over the network, it's not so easy. Because Grub normally, when you start from the disk, is using firmware FE services, UEFI services to access the local disk to load configuration, kernel, etc. But when you start the system over the network, UEFI services not always register the protocol to access local disk. It also depends on the specific machine. In some cases they do, in some they don't. So in that case, okay, I have Grub. Grub has quite a bit of drivers for various storage. So if the local disk is AHCI, then I can use Grub to access the local disk using the driver that is in there. But for NVMe, Grub does not have a driver. Normally it relies on firmware, but when starting on the network, it's not disk access services are not there. So to boot from the local disk, it gets tricky. So what I ended up doing is boot over the network, boot Linux with very small initial RAM disk. And this initial RAM disk changes the boot order, so the next boot is started from the local disk and then reboot the machine. There are probably a few alternatives. like loading this Linux and then using kexec to start from local disk, or trying to affect the boot order some other way, maybe some firmware setting. But this approach I use works on most machines I have, and it makes the boot handling uniform. Because yeah, every single one of them is different. So and I'd like to have a uniform interface how to control them, because otherwise I would need to restructure tests depending on which machine they run on, and yeah, I don't like that. So in this boot diagram, there are different options for this. Normal, either just chain load to grab directly, or boot to something that will set boot next variable and then reboot. Yeah. Okay. So this is this SSH connection, and I use this recently. The same setup, not only to OpenQA but also to also manually test, well, semi-manually test some things. For example, I have a script that uses this boot control to do kernel bisections. So when I debug something, I can set it to upload I have a script that uploads the kernel to be tested to this controller, and set up boot order to start from something loaded over network from here, wait for the system to start, and then run some simple tests like whether ping works or whatever. If I'm debugging just some boot problem, boot crash, then just ping. If not, then SSH and test some stuff, and then report the results. And this way I can connect it as git bisect run script, so it does all the bisection automatically, iterating, so I can leave it for the night, and in the morning I have the results, which is nice. But for that, I need also a connection back from this controller to individual workers to control these input devices. In that case, I don't capture video output, so it's not used. But yeah, for input devices, I need that. And in some rare cases, I have system that has a real serial console, and it's also connected to the Raspberry Pi. This on the left. So I also have interface to connect and capture serial output. Yeah. If serial console is there, it's the most convenient way to capture crash messages. And okay, so I think that's about the hardware setup here. So what else I have in OpenQA configured? So there's this flash script I was showing already, store asset. Yeah, the serial. OpenQA requires some serial, expects some serial to work. Well, it can work without, but it's a bit painful because all the commands like assert script run or stuff like that depends on the serial port. So if I have a real serial connection, then I use that. If I don't, I emulate that over TCP. And this is set up, this one. Yeah. So in some cases, there's some wrapper setting. In some cases, it's connected to serial console on Raspberry Pi that is physically connected to the port. In one of the cases, I have USB converter in the middle, so I use that. But in all the other cases, I have a simple connection. It's using bash built-in to connect over some specific port. And on the target system, on the system under test, maybe here, I have, oh no, don't, well, okay, too late. I replaced the, I think this is the fun one. I replaced def HVC0, the real one, I replace with a pipe, and then I start a netcat that is connected to this port, and then simply print out whatever was putting into the whatever was printed into the console here. I'm using HVC0 and not TTY-S0 because in cases where I have physical console, it is connected as a console to Zen hypervisor because CubeSource is running on Zen. And then, so I have hypervisor logs on the console, and then Linux can print to the hypervisor console that is printed to physical console. That's why this is HVC0 and not TTY-S0. Okay. So that's how serial console works. And the power ons, power and power off scripts are using this many over SSH I was showing before. So there is power on and possibly also boot mode. This boot mode is either OpenQA to boot something specifically like from this network boot. If there is an ISO image, it also mounts it, so the content of the ISO is published over HTTP. Or I switch to normal. When there is no ISO image, then it's boot from the local disk. And there is some hack to wake the system. If I do power on action twice, so the first one will power on, and then it will touch this TMP is power on flag file, and the next time when I execute power on, it will say, okay, this file is present, so I execute wake option. That's because I don't have separate script to connect or action to connect in OpenQA. I have only power on and power off. So I needed some way to distinguish those actions. Okay. Yeah. So this is, I think, most of it. So the whole repository, as you can see here, has a bunch of SLS files. This is a configuration for salt stack to set this Raspberry Pi on the left to install all the necessary stuff, copy all the scripts, and configure everything. Yeah, I have about 10 of them, so I don't like to do that manually. So I have an automation for that. So I just flash some OpenSUSE tumbleweed to SD card, just this the simple image, and then run salt to configure everything else. So I have the main OpenQA worker, and it's also adding some repository for FFmpeg, install some packages, yeah, create the configuration file for the worker, yeah, configure the secrets. Secrets are not stored in this repository; they are in separate file, of course. Yeah, there is a sudo configuration, so this OpenQA worker can call some of the scripts as root. Yeah. And for the SSH access, so where was that? Oh, not here. Okay, but for SSH access, to access this menu I was showing before, oh, this one, I need some authentication. So I don't use password authentication from that script, but I set up SSH agent that is just separate systemd service, and the worker has access to the socket of this SSH agent. So all the SSH access simply connect with key authentication. Yeah. So I don't need to worry about the passwords and stuff. And in fact, I use also SSH agent when I need to connect to, using SSH to the target, to the system under test. It's also using key authentication using the same SSH agent. So yeah, I don't have passwords there. Okay. So that's the setup. And then how does it look from the OpenQA side? I have some test schedules, and I configure. Let me find it here. I have separate machines configured. It is HW and some number, and those have a specific worker class. Is worker class set here? No, it's in machine. Let me try. Does it work? Yes. I'm not logged in here, so I need to guess the URLs. Yeah, so machine HW1 has worker class HW1. 2 is the same, etc. And workers have this worker class assigned. So in my test schedule, I manually assign which test is running on which machine. It is a bit limiting because I have some of the machines are very similar, so I could let OpenQA to manage the schedule. So, for example, test could run in parallel depending on which workers are available. But due to this issue with due to how I handle disks, I need to control what is running where. So yeah, this is how I've done it. And there is of course various setups like what is the serial console in particular machine, is it UEFI or not, because it affects how the boot order is configured. There is this is Cube specific USB VM. Yeah, I think others are. And there is also USB boot. In one or two of them, I gave up with this network boot setup because it was horrible. So actually is boot from USB that is emulated here. It is slower and it's not as flexible as the network boot, but yeah, it's enough. Okay, so this is how my test schedule looks like. Yeah.
If you like,
Okay.
you can also show some tests, so we
Yeah,
also see what you are actually testing here.
Yeah, of course. No, maybe not here. So let me find. Those are interesting. I have two type of tests. Some of them are I would call OpenQA native. Let me let this load. Okay. So, for example, I start some web browser and yeah, I'm looking for some clipboard, some notification, etc. So this is how things work normally, the same as on the KVM would normal how it would work on KVM. But as you can see, the worker is HAL 9000 something. So this test was running on physical machine. I wonder if it's visible here at all. No, not really. On some of machines, the video output is you can also see firmware startup, and that it's actually some laptop. In most of them, the video output on HDMI starts quite late in the boot process, so I don't have video from the very early process. And those tests that are run here looks normally like assert and click, type string, send key, normal stuff. So this works normally. But also I have another type of tests that I call system tests here. And this, if I find the right screenshot, this one, yeah, probably. So it's in fact running all the tests using Python unit test framework. So all the tests are run as just a single command from the OpenQA point of view. But then I think I have the command. Yeah, I have the command here. So it's in fact using nose runner, and that is saving output results in JUnit XML format. And then I load this XML. I need to do some post-processing on it. Yeah, it's stupid, but there, there is JUnit XML format, but in fact, it's not really standard, and every single tool use it a bit differently. So yeah, I need to do some post processing to to make it in a format that OpenQA understands. And then I load it as external tests, so I have all the test results here. And if I have some failure, no, this one was successful one. So let me find some failure. Yeah, okay. This without HW is running on emulated, but it's the same thing. So I'll show the failure here. I also have some results, some diagnostic messages collected here. And also I made a script that if there is a failure, on each test I have a timestamp. So I look over all the system logs and collect logs from that particular time. So for example, for this one failure, I have these 3 logs with just the stuff that happened during this test. So yeah, in this case, I have some console output from VMs running inside this Cube system. This is a really time saver, because when I run several tests in a single test run, this test is missing something. Normally, I also have a tarball of the whole var log uploaded here, but apparently it's not this time. Oh well. But also, when I have all the logs, I would need to manually look for what happened during this specific time. And with this script, I have logs extracted for the specific failure. And the installation, the first test that is run on the machine. In this test run, there was just one hardware-based test. First test is just installing the system. So yeah, it's running the installation normally. And I think there will be some something. Oh no. Yeah. And it detects the USB keyboard and mouse is here, marmarek RP4 USB gadget. So this is the stuff emulated from this Raspberry Pi connected. Okay. Oh, and if you are interested in this logs filtering, I can show you where this script is. So there is this repository test HW setup, which is just set up for the Raspberry Pis for hardware-based setups, and OpenQA tests CubeOS. This is a repository with all the tests, either for the hardware or for emulated cases. And when it loads, I have some extra files, and there is split logs script. So it is iterating. There, obviously, each log has different timestamp format, because yeah. But the script has hard-coded paths with which logs it will look at. So there is var logs then console, and I think there was some more. Oh, maybe not here. Okay, but it looks and then loads the timestamp from the JUnit XML. It looks from the timestamp of start and end, test end, and then iterate over those logs and split the logs.
Yeah, I must say, a very interesting talk. Many details, and for instance, I found particularly interesting how you deal with the mouse. Yeah, that was surely not so easy to set up. Everything looks kind of sophisticated. I mean, a lot of different pieces needs to come together. That, yeah, really looks a bit advanced. Also nice that you use Salt to deploy it. And in general, it is also nice to see that you use certain OpenQA features we've been working on for actually some other purposes, but it's nice to see that they are generally useful.
Yeah, it was a challenge to set up. So there is this article version of this, basically what I've said here. it has some. Okay, this article is about a year old, so some stuff evolved. But if you are interested in some details, I think most of the stuff is captured here, and it's still quite accurate description. So,
Yeah, I also like the picture with servo. Reminds me of model crafting.
yes, in fact, this is why I use that, because I did some model crafting in the past, so I knew how to use them. Those.
Yeah, it's actually a good idea. I mean, sometimes you just can't help but actually press a button.
Yeah. Getting this laptops to power on, it was, yeah. I was using a lot of different options. For the desktop systems, you have this front panel connector on the main board. You can simply connect whatever you like there. And in fact, one of the tests is using desktop system, and I simply connect Raspberry Pi there and connect that, control that pin directly. But for laptops, yeah, every single one is different with different firmwares, and some works better and some requires actually pressing the button. And also some needs to actually be open. I cannot close the case and close the lid and press the button, because it would be ignored. Also, depending on the specific model. It's annoying. But in CubeSOS, we focus mostly on laptops, so I needed to make it working on laptop.
Yeah, I'm not sure how many people are still following to this point, but if you have any questions, feel free to ask now at the end. Yeah, of course, we also know you're in our OpenQA channel on Matrix, so we can definitely stay in touch. And of course, I was also aware of certain details because you already created certain pull requests, for instance, for the FFmpeg recording. Yeah, so that's also nice to see, contributions, not only from SUSE employees.
Yeah, in general, I'm very happy about OpenQA. There are some things that I needed to change, but I think all the changes I needed in OpenQA are sent back to upstream. So yeah, I'm very happy about that.
Okay, so it's been almost an hour, so I will stop the recording.